Welcome to Chapter 9 of the AEON-CASIMIR Dossier, where we dive into the heart of energy harvesting, vacuum loading, and power closure. Building on the foundations set in previous chapters, covering propulsion, gravity redistribution, coherence, and stability, this chapter focuses on how the AEON-CASIMIR craft sources, circulates, buffers, and conserves energy. The key takeaway is that the system does not extract free energy or violate the laws of physics. Instead, it operates as a vacuum-loaded energy recycler, ensuring all energy is accounted for and conserved. Let's explore how this unique approach shapes the craft's operation. AEON-CASIMIR's operation relies on four tightly coupled energy domains. First, electrical and electromagnetic energy powers command, control, and plasma excitation. Second, plasma internal energy acts as a buffer absorbing and translating frequencies. Third, vacuum zero-point energy, which is dependent on boundary conditions, plays a subtle but crucial role. Finally, gravitational or metric energy enables curvature redistribution. Together, these domains ensure that the total energy in the system remains constant, with energy shifting between forms, but never lost or created from nothing. Central theme in AEON-CASIMIR's design is strict adherence to energy conservation. The total energy, comprising electromagnetic, plasma, vacuum, and metric components, remains constant throughout operation. This closed-loop accounting ensures that the craft does not generate energy from nothing, but rather recycles and redistributes what is already present. This principle is foundational, aligning the system with established physical laws and preventing any violation of the first law of thermodynamics. Unlike some speculative technologies, AEON-CASIMIR does not extract energy directly from the vacuum. Instead, it employs a process called vacuum loading. Here, energy differences arise only when the boundary conditions of the vacuum are changed. This energy is borrowed temporarily, stored in phase, and then returned during system reversion. The Casimir effect, often misunderstood as a source of free energy, is used here strictly within the limits of established physics, ensuring no net extraction from the vacuum itself. Key to vacuum loading lies in manipulating boundary conditions. By changing the configuration of boundaries, the system can temporarily access energy differences. However, this process is strictly controlled, energy is always returned, and the vacuum is never depleted. This approach ensures that the AEON-CASIMIR craft operates within the boundaries of known physics, borrowing energy only as allowed by the system's configuration and returning it promptly. Casimir energy density is a function of the separation between boundaries. As the separation decreases to the nanoscale, energy density increases dramatically. However, this effect falls off rapidly at large scales, naturally limiting the amount of energy that can be accessed. This scaling ensures that the system cannot experience runaway loading or macroscopic vacuum collapse, keeping operations safe and predictable. A rapid decrease in Casimir energy density with increasing boundary separation acts as a built-in safety mechanism. This natural limit prevents the system from accessing dangerous amounts of vacuum energy, ensuring that no macroscopic vacuum collapse can occur. The AEON-CASIMIR design leverages these physical constraints to maintain operational safety at all times. Within the AEON-CASIMIR craft, plasma rings serve as dynamic energy flywheels. They absorb transient power spikes, store energy as both magnetic and kinetic stress, and release it during phase corrections. This buffering action helps stabilize the system against oscillatory instabilities, ensuring smooth and reliable operation even during rapid changes in energy demand. Energy stored in plasma is a combination of thermal and magnetic components. This dual storage capability allows the plasma to act as an effective buffer, absorbing excess energy when needed and releasing it to maintain system coherence. By functioning as an energy flywheel, the plasma ensures that the AEON-CASIMIR craft remains stable and responsive under varying operational conditions. What appears as thrust in the AEON-CASIMIR craft is actually the result of metric work, energy expended to reshape spacetime itself. Unlike traditional propulsion, which relies on accelerating mass or expelling reaction mass, this approach uses energy to alter the curvature of spacetime. This explains the craft's ability to achieve high acceleration without power spikes, exhaust, or reaction mass. AEON-CASIMIR's propulsion is fundamentally different from conventional engines. By expending energy to reshape the local spacetime metric, the craft moves without the need for traditional fuel or exhaust. This innovative approach allows for efficient, high-acceleration maneuvers while maintaining energy conservation and system stability. When the AEON-CASIMIR craft decelerates, lands, or reverts to Newtonian mode, it recovers metric energy and returns it to the plasma systems, electromagnetic storage, and structural field damping. This regenerative loop is similar to dynamic braking in electric vehicles, allowing the system to recycle energy efficiently and maintain overall energy closure. The concept of regenerative energy recovery in AEON-CASIMIR is much like dynamic braking in modern electric vehicles. Instead of wasting energy during deceleration, the system captures and stores it for future use. This efficient energy management strategy helps maintain the craft's energy balance and reduces overall power consumption. To initiate and sustain operation, the AEON-CASIMIR craft requires onboard power for several key functions. These include plasma ignition, frequency locking, boundary modulation, and control electronics. Once the system achieves coherent operation, its steady-state power demand drops sharply, making it highly energy-efficient but not energy-free. Critical distinction in AEON-CASIMIR's design is that it is energy-lean, not energy-free. While the system operates with remarkable efficiency, it still requires an initial energy input and ongoing management. This disciplined approach to energy use ensures compliance with physical laws and prevents misconceptions about perpetual motion or free energy. Under certain conditions, the AEON-CASIMIR craft can weakly couple to external energy sources, such as ambient electromagnetic fields, planetary magnetic fields, or gravitational gradients. These external sources provide assistive energy but are never primary or destabilizing. The system's stability and safety are always maintained, regardless of external influences. The ability to couple with external fields allows the AEON-CASIMIR craft to operate more efficiently in certain environments. However, these sources are strictly supplementary. The craft's core energy cycle remains closed and self-sufficient, ensuring that external energy does not compromise system integrity or safety. Waste heat is a common challenge in advanced systems, but AEON-CASIMIR minimizes it by keeping most energy phase coherent and redistributing heat through plasma and electromagnetic cycling. Only a small fraction of input energy is lost as heat, making the system highly efficient and reducing the need for extensive thermal management solutions. By cycling energy through plasma and electromagnetic systems, AEON-CASIMIR effectively redistributes heat, preventing localized hotspots and maintaining operational stability. This approach ensures that the craft remains cool and efficient, even during extended or high-intensity operations. Safety is paramount in AEON-CASIMIR's design. The system enforces strict energy caps through frequency detuning, boundary relaxation, and decoherence triggers. If energy density approaches critical thresholds, automatic unloading mechanisms activate, ensuring that the system never exceeds safe operational limits. When energy density nears its maximum safe value, AEON-CASIMIR automatically unloads excess energy. This proactive approach prevents dangerous conditions and maintains the integrity of the craft's systems. Safety protocols are deeply integrated into every aspect of the energy management cycle. AEON-CASIMIR's operation is fully consistent with established physics, including the first law of thermodynamics, general relativity, and quantum field theory. The system does not create energy, it simply rearranges existing energy pathways to achieve its remarkable performance. A common misconception is that advanced propulsion systems like AEON-CASIMIR operate on free energy. In reality, the craft's performance is rooted in disciplined energy management and strict adherence to conservation laws. There are no shortcuts or violations of physics, just innovative engineering. Chapter 9 ties together key concepts from earlier chapters, including boundary physics, gravity exchange, and coherence control. Without the energy closure mechanisms described here, the advanced functions detailed in previous sections would not be possible or safe. This integration ensures a holistic and robust system design. The concept of energy closure is central to AEON-CASIMIR's safe operation. By ensuring that all energy flows are accounted for and recycled within the system, the craft avoids the risks associated with unchecked energy accumulation or loss. This disciplined approach underpins the reliability and safety of the entire platform. In summary, Chapter 9 establishes AEON-CASIMIR as a conservative, boundary condition-dependent system. Plasma acts as a dynamic energy buffer, and apparent propulsion arises from metric work rather than traditional thrust. The system is regenerative, energy-lean, and fully compliant with the laws of physics. This disciplined approach to energy management is what sets AEON-CASIMIR apart. AEON-CASIMIR's design explicitly avoids the pitfalls of perpetual motion or free energy claims. Every aspect of its operation is grounded in established science, with rigorous energy bookkeeping ensuring that nothing is created or destroyed, only transformed and recycled. The craft's success hinges on meticulous energy bookkeeping across all domains. By tracking and managing every joule, AEON-CASIMIR maintains operational integrity and avoids the risks of energy imbalance. This discipline is a hallmark of advanced engineering and a key reason for the system's reliability. A unique feature of AEON-CASIMIR is its reliance on boundary condition-dependent energy management. By carefully controlling the boundaries within which energy operates, the system can achieve remarkable effects without violating any physical laws. This approach is both innovative and fundamentally sound. Plasma is more than just a medium in AEON-CASIMIR, it's a dynamic participant in energy management. By acting as a buffer and flywheel, plasma absorbs, stores, and releases energy as needed, smoothing out fluctuations and maintaining system coherence. This dynamic role is essential for stable, high-performance operation. The concept of metric work is at the core of AEON-CASIMIR's propulsion. By reshaping spacetime, the craft achieves movement without traditional thrust mechanisms. This innovative use of energy allows for efficient, high-acceleration travel while maintaining strict energy conservation. AEON-CASIMIR's regenerative energy cycle ensures that energy used during acceleration or maneuvering is recovered during deceleration and landing. This closed-loop system maximizes efficiency and minimizes waste, setting a new standard for advanced propulsion technologies. Once the AEON-CASIMIR system reaches coherent operation, its power requirements drop significantly. This steady-state efficiency is a testament to the craft's advanced design, allowing it to operate for extended periods with minimal energy input while maintaining full functionality. A large part of AEON-CASIMIR's efficiency comes from keeping energy phase coherent. By minimizing energy dissipation as heat and maintaining coherence across all domains, the system reduces losses and enhances overall performance. This approach is a key factor in the craft's advanced capabilities. Prevent unsafe energy accumulation. AEON-CASIMIR employs decoherence triggers. These mechanisms disrupt phase coherence when energy densities approach critical thresholds, forcing the system to unload excess energy and maintain safe operation. Frequency detuning is another safety feature built into AEON-CASIMIR. By shifting operational frequencies away from resonance points, the system can reduce energy density and avoid dangerous conditions. This proactive management keeps the craft within safe operational limits at all times. Boundary relaxation allows the AEON-CASIMIR system to safely dissipate excess energy by adjusting the boundaries that define its operational domains. This flexibility is crucial for maintaining stability during dynamic or unexpected events. AEON-CASIMIR incorporates multiple overlapping mechanisms to ensure system stability. From plasma buffering to automatic unloading and frequency detuning, every aspect of the design is focused on maintaining safe, reliable operation under all conditions. AEON-CASIMIR's adherence to the first law of thermodynamics, general relativity, and quantum field theory ensures that its operation is not only advanced, but also scientifically sound. This compliance is essential for credibility and long-term viability. One of the most striking features of AEON-CASIMIR is its lack of exhaust or reaction mass. By relying on metric work rather than traditional thrust, the craft achieves movement without the need for fuel expulsion, setting it apart from conventional propulsion systems. The ability to achieve high acceleration without power spikes is a direct result of AEON-CASIMIR's unique energy management. By reshaping spacetime rather than accelerating mass, the craft can maneuver rapidly and efficiently, all while maintaining energy conservation. During rapid maneuvers or energy spikes, the plasma rings absorb and buffer excess energy, preventing instability. This real-time energy management is crucial for the craft's ability to handle dynamic operational demands without compromising safety or performance. AEON-CASIMIR's closed energy loop means that energy is constantly recycled within the system. Whether during acceleration, deceleration, or steady flight, every joule is tracked and reused, maximizing efficiency and minimizing waste. The principles outlined in Chapter 9 have far-reaching implications for the future of propulsion and energy management. By demonstrating that advanced systems can operate efficiently, safely, and within the bounds of known physics, AEON-CASIMIR sets a new benchmark for technological innovation. In closing, Chapter 9 of the AEON-CASIMIR Dossier provides a comprehensive look at how disciplined energy management, boundary condition dependence, and innovative engineering come together to create a safe, efficient, and scientifically sound propulsion system. The craft's ability to recycle energy, maintain stability, and comply with physical laws is a testament to the power of thoughtful design and rigorous science.